So in this video we're going to talk about why percent change is important when you're analyzing the data from an experiment. The main thing is that it tells you whether or not you actually had any impact on your results. So if there's 0% change, then it means that the experiment didn't affect the results at all. However, if this percent change is greater than 0, it means that whatever you did during the experiment did impact the results. And it's simply an equation. It's actually one you're going to need to memorize. Some equations will be provided for you. This equation is not provided for you. It's one that you'll need to memorize. It's not too difficult. It's just a calculation of the percent change by subtracting the initial value from the final value and dividing it by the initial value and then multiplying by 100 to get it into a percent. If you don't multiply by 100, then it's expressed as a decimal instead of a percent. So we're always going to multiply by 100. So here's some data that I made up from a potential experiment. Let's say you're looking to measure the impact of temperature on the amount of glucose produced by an enzyme. So you take some milk and you add the lactase enzyme to it, and you're going to put those test tubes at different temperatures and see if changing the temperature affects how fast the enzyme works. And so your initial readings are 10 milligrams of glucose per deciliter of the solution, and that's because all milk has a little bit of glucose in it at the starting point. So you run your experiment and your final values are tabulated here, and I'm going to talk you through how to calculate percent change for each group. So for the 0 degree Celsius trial, the final value is 10 milligrams per deciliter. The initial value is 10 milligrams per deciliter. So if you take the final value minus the initial value and you divide by your initial value, you're going to have 0. And when you multiply 0 times 100, you get 0. So in this case, there was 0% change, which means that putting the test tube at that condition made no difference in the results. However, as you look at the 10 degrees Celsius trial, in this column, you'll see that the final value is 15 milligrams per deciliter, and the initial value was 10 milligrams per deciliter. So when you plug those numbers in down here, 15 minus 10 is 5, divided by 10 times 100 gives you 50% change. And this makes sense if you look at your data. So if the initial starting point is 10, half of 10 is 5, right? And you went up by 5, so you went up by 50% of your initial value. In the trial that has 20 degrees Celsius, I made this up just as a demo purpose. We wouldn't expect this data to look like this, but I made it a negative value. So in this case, just so we could talk about what that means, your final value is negative 15. Your initial value is positive 10. So if you take negative 15 minus 10 and divide by your initial value of 10, multiply that by 100, you're going to get a negative percent change. So this is saying that the amount of glucose actually decreased by 250% from the initial value. And again, this makes sense because if you start at 10 and you end at negative 15, it's gone down by an entire unit of 10, a second entire unit of 10, and half again by 5. So you've got negative 250% change. For the 30 degree Celsius trial, you'll see that the final value is 50 and the initial value is 10. So when we take 50 minus 10, it gives us 40, and we divide by 10 and multiply by 100, we get 400% change. That's a really big value, 400% change. Let's see if it makes sense. So you started with 10 milligrams of glucose per deciliter in your solution, and when you heated the test tube to 30 degrees Celsius, you ended up getting 50. So that is significantly more than what you started with. The reason it's 400% change is if 10 represents 100%, 20 you've increased by an additional 10, right? So that's 200% change. If you increase by another 10 milligrams to 30, that's going to be an additional percent change, and then you go up to 50, you end up at 400% change.